Welcome back to Chapter 14 and 15, Part 9 of the Introduction to Inference. In the last segment, we finished up with talking about what type of errors could be involved in hypothesis testing. Now we're going to put everything together and actually do a hypothesis test. Let's remember the three assumptions that we are assuming in order to do the z-tests in Chapter 14 and 15. First, we have a simple random sample from the population of interest. The variable we measure has an exactly normal distribution in the population, or the sample size is 30 or more, so that the central limit theorem can be evoked for the sampling distribution. In other words, the sampling distribution of the sample mean must be normally distributed or approximately normally distributed. Number 3, we do not know the population mean, but we do know the population standard deviation. If those three conditions are met, we're now ready to do the 6-step hypothesis test. Step 1 is to state the null and alternative hypothesis. You'll find that in the question that you are trying to answer. Number 2, state the significance level. In our class, we'll give you the significance level. Remember what that is. It's the probability of a type 2 error, and it's our benchmark for how we're going to reject or not reject the null hypothesis. Step 3 is to calculate the test statistic. The test statistic being how many standard deviations our sample mean is in the null hypothesis distribution. And remember, the null hypothesis distribution is the sampling distribution of the sample mean for samples of that specific size. The next thing we'll do is calculate the p-value. This is just one method for making a conclusion to a hypothesis test. There's the classical method, the p-value method, or using confidence intervals, believe it or not, in order to determine whether we'll reject or not reject the null hypothesis. But in our class, in the Introduction to Statistics 1, we're going to concentrate on the p-value method. So on the 4 steps, we're going to actually calculate the p-value. And then in Step 5, determine whether you reject or do not reject the null hypothesis. Part 6 is state the conclusion in the context of the problem. So let's look at our first example. This is an example of a right-tailed test. The National Health and Nutrition Examination Survey are designed to assess the health and nutritional status of adults and children in the U.S. According to a recent NHANES survey, the mean height of adult men in the U.S. is 69.7 inches, with a standard deviation of 3 inches. A sociologist believes that taller men may be more likely to be promoted to positions of leadership, so the mean height, that is mu, of male business executives may be greater than the mean height of the entire male population. A simple random sample of 100 male business executives has a mean height of 69.9 inches. Test the sociologist's claim that the male business executives are taller on average than the general male population at a 0.05 significance level. So, first of all, we have to make sure that all the assumptions are met, and we're going to assume, they tell us that a simple random sample of 100 male executives, business executives, so condition number 1 is met. Number 2, is the sampling distribution of the sample mean for samples of size 100, is it normally distributed? Well, since we have a sample size of over 30, we can invoke the central limit theorem. Therefore, the sampling distribution is approximately normal. And that sampling distribution is our null hypothesis. And the third condition is met with the standard deviation of 3 inches. We'll assume that that is the population standard deviation because we were given the population height. So all 3 conditions are met, and now we're ready to begin our hypothesis test. So this slide shows that all the 3 conditions are met. So we're going to state the null and alternative. We'll state the significance level, which was given in the problem as 0.05. We'll calculate our test statistic, then we'll calculate the p-value, and then we're going to determine whether we're going to reject or not reject the null hypothesis. We're going to state our conclusion in the context of the problem. So how do we do these things? Well, here we go. Well, we've done a little work with stating the null hypothesis. You read the problem, and that's how you know what the null hypothesis is and what the alternative. As I stated, the significance level will be given to us in most problems, and in this problem, our alpha was 0.05. If we don't see a significance level, we'll just assume that it's 0.05. How do we calculate the test statistic? And again, what is that test statistic? The test statistic is how many standard deviations your sample mean is in the null hypothesis distribution. In other words, it's just getting a z-score. Calculating the p-value, well, that's what we're going to learn how to do in the next several slides. And then, how do we determine whether we reject or not reject the null hypothesis? Well, this will stay true for all p-value problems. If the p-value is less than our significance level, we're going to reject the null hypothesis. If the p-value is greater than or equal to our alpha, our significance level, we do not reject the null hypothesis. I just went on and changed the A to alpha. I'm sorry that wasn't there before. I hope your PowerPoints are corrected. If not, go on and correct those. So remember, alpha is our significance level. So if the p-value is less than alpha, we reject the null hypothesis in favor of the alternative hypothesis. And if the p-value is greater than or equal to alpha, we do not reject the null hypothesis in favor of the alternative. Once we determine that, we can now state the conclusion in the context of the problem. If you reject, you have sufficient evidence to go with the alternative. If you do not reject the null hypothesis, then you have insufficient evidence to go with the alternative hypothesis. We never accept the null hypothesis. We just say we don't have enough information or enough evidence to reject it. So what is this p-value? The p-value is the probability of observing a sample mean that is as extreme or more extreme than the one you've observed. That is, you take your mean of your sample and see where it lies in the null hypothesis distribution, and depending on whether it's a right, left, or two-tailed test, you see how far it is in the appropriate tail end. Now, the probability is calculated assuming that the null hypothesis is true. We use the p-value to quantify how unlikely the observed sample mean is. It becomes a basis of our reject or do not reject decision. So in other words, if we find a mean very, very, very far out in the tail end, that's unusual and shouldn't have happened. And that will be our basis for saying we would reject the null hypothesis. But we'll see how all this works. What sample means are as extreme or more extreme than the observed depends on the alternative hypothesis. So the formulas for calculating the p-value depend on the alternative hypothesis. So the p-value is a statement about the probability the sample mean takes on specific values. It is not a statement about the probability that the population mean has a certain value. It is not a statement about the probability that the null hypothesis is true. Another way to look at the p-value, the p-value can also be defined as the probability of committing a type 1 error based on your sample. So if the p-value is large, that indicates that the probability of making a type 1 error is great. If that's true, you won't feel comfortable rejecting the null hypothesis. But if the p-value is small, that indicates that the probability of making a type 1 error based on the sample that you took is very small. And if it's very, very small, then you'll feel comfortable rejecting the null hypothesis. You'll feel like you have proper evidence to support the claim that the alternative is true. But how small is too small, or how large is too large? When stat 250, if the p-value is less than your significance level, which is alpha, then the p-value is small enough to feel comfortable rejecting the null hypothesis. If the p-value is greater than or equal to our significance level, alpha, then the p-value is large and you will not feel comfortable rejecting the null hypothesis. You'll have insufficient evidence to support the alternative claim. So how do we get the p-value? Well, to test a claim using the p-value approach, the first thing you have to do is calculate the observed value of what's called the test statistic. And since we're in a z-test, it's called z-naught. And this is how you would calculate z-naught. Now, in the next installment, In part 10, we're going to actually get more into how do we calculate the p-value, and then we're going to continue with example 1 and complete the example. Thank you.